In this video we are going to discuss about the FPGA architectures. So on completion of this topic, the students will be able to learn the new concepts from the industry experts, and they can gain a foundational understanding of a subject or a tool. So the main thing here overall presentation is, here we are going to see the available choice of digital designer, this detailed look of this FPGA and their interconnections, field programmability, that is SRM, antifuse, EEPROM, and the commercially available devices, that is Xilinx XE4000 and Ultramax 4000. So mainly this FPGA depends on this works on the principle of functional completeness, and this field programmable gate arrays or the prefabricated silicon devices which is electrically programmed in the field to become almost any kind of the digital circuit or system. So low to medium volume productions, this FPGA is very cheaper solution, and it is very faster time to market as compared with the other integrated circuits. This requires lot of resources in terms of either time and also in money. So this interconnection framework consists of the wire segments and the switches. This provides a means to interconnect the logic blocks, and the circuits are partitioned into logic block size, mapped and root. So you can see the basic building blocks of this one. This programmable logic block is implementing logic function, and programmable routing connects these logic function, and IO blocks that are connected to this logic blocks are passing through the routing interconnect, and also they can make of chip connections. And here this logic block is consist with 3 select inputs, and maximum with its output is driven in the D flip flop. Here also this number of programming technologies which we are using here have the significant effect. Also this includes major cells, that is if you are giving more number of cells which is dividing through in this FPGA, can be providing the configurability. The main thing this program, the routing interconnect of all this FPGAs will be generally steered by the smaller multiplexers. And this basic blocks of this multiplexer will having the programmable memory element that is used to implement the logic functions. Interconnection framework. So in this interconnection framework, you can see the inputs, IO blocks, CLB blocks, that is configurable logic blocks. These configurable logic blocks are surrounded by the input blocks, and here you can see the holding devices. So this FPGA is mainly the finely grained variable length. This interconnect segments are surrounded by the IO blocks, and the timing is predictable. It is extracted after the replacement and the route. And in the interconnection network, you can see the CPLD. So mainly this programmable logic consists of the programmable crossbar which interconnects the structure. These interconnects are made up of the metal lights as shown in this diagram. The switch matrix are fully populated, that is it is fully populated along the CLB blocks, and the timing is very predictable, and its architecture does not scale well. That is, the dynamic power of the conception of new process will be having the metallic shades, so that these inputs and the output blocks are surrounded by the CLB blocks. So this transforms the information from one to another. Each CLB blocks are connected in a series and parallel way. And next is the flash programming technology. That is, flash programming technology is having the two advantages as well as disadvantage. It is more efficient, but it has the it does not have the any recognized or reprogrammable in the infinite number of the lines. And also, as we said, we are antifuse programming technologies are mainly used in the low area, and it has lower on the resistance, and the parasitic capacitance is very high, and it is non-volatile. So the major disadvantages is it does not make any sense of standard CMOS process, and this is widely used in the reprogrammable. It can be reprogrammable, non-volatile, and also used in the standard CMOS process. This field programmability is achieved through the switches, because the transistors controlled by the memory elements of the switches achieved is normally used as a switcher, and this switch will control the following aspects here. Since the interconnection is made along the wire segments and the CLB blocks, this switches will control the major things of the CLB and the wires. And the distributed memory elements that is controlling the switches on the CLB blocks are together, we call it as configuration memory. The major designs involved in the designing with the FPGA: first we are specifying the design and giving the entry, next it is synthesized, next it should be mapped. So while mapping, it should find the fixed CLP blocks, as well as the fixed, while identifying the fixed blocks, it should place and route the particular position. Next, the proper timing constraint should be given. Next, it is programmable and test and driven for the final steps. And the next one is Xilinx FPGA. So in Xilinx FPGA, this is nothing but it is array based or symmetric array based. It consists of the CLB blocks with the flip flops. Here also we have the n inputs. It implements the n input boolean function, and the arrays are embedded in the IO blocks. That is, IO blocks are surrounded by the CLB blocks are surrounded by the IO blocks, and these array elements are interleaved with the routing resources, that is wire segments, switch matrix, and single connection points. So this we call as RAM technology. In XE4000 CLB, here we have 3 LUTs and 2 flip flops, 2 outputs. So this external signals can also be registered. Mostly these internal signals are not available, or available for the connection, and also they can implement only the independent functions of the different variables. So you can see the structure of this XE4000. This routing structure is connected with the metallic lines, and it has a switches inside it. So these lines will give, these wires are connected to each other to form the CLB, to connect it to CLB blocks, and finally it is connected to the IO blocks. Here, this XE4000 routing architecture contains the wire segments, which is consist of the single length lines and double length lines. So in single length lines, it spans the single CLB and connects the adjacent CLBs. It's also used to connect the signals that does not have any critical timing requirements. In the double length lines, it spans two CLBs and uses halves as a switch as a single length connection. In the case of long lines, you can see the signals as a clock. And the switch matrix, it is connected to 3 direction, which requires 6 transistors. So you can see the taxonomy of the FPGA. In FPGA, it has 3 types. One is SRM program, anti-fuse program, and E program. In SRM program, contains Iceland and cellular. Quiz questions: what is FPGA? What logic is inferred when there are multiple assigned statements targeting the same wire? Thank you.